Monday again, boys' night out. We're back down here at the shed. We're going to continue wiring the pinball machine. Mike ordered some more yellow wire. It came in, and so we're ready to continue wiring the relays up in here that I had to stop wiring last week because we ran out of wire. I am probably not going to film that. I mean, you guys probably saw way more than you needed to of the wiring last week. So I'm just going to get in there and do this wiring, crimp on connectors just like we did last time, and hook it all up. And then we'll bring you back and show you the testing of all of those solenoids. We'll probably try and wire the chimes in after that, and then probably wire in the flippers, although the flipper switches on the front of the box need to be reinstalled and wires need to be brought up. And once we finish testing out all the solenoids, we'll move on to terminating all the switches and testing out the switches. So I'm not sure we'll get all the way through all of that wiring. There are a lot of switches to crimp and wire and test, but it is what's on the agenda for today. So wish us luck. Okay, I've finished wiring on the yellow wires. As you can see, I've connected wires to here, here, and here. Those were the wires I had on last week. You may be able to see, I'm not sure, these wires are a little bit thicker. They're actually the same gauge, just the insulation that's a little thicker. And all of these wires come back to this massive bundle of wires. Ignore those white ones. This massive bundle of wires right here. And all those yellow wires have to connect to this connector. Now you'll notice there's a lot more yellow wires here than there are in this connector. And that's because each of the 10 relays, well, these are the 10,000 relays, each of the 10,000 relays have to get connected together, and then one of those goes into this connector. And then each of the thousands relays, same thing, tens relays, and ones relays. So these are going to be bunched together, and they're going to end up making just 4 wires that go into this bundle. There are still some wires that need to be hooked up to the score wheel. I'll take care of those later. I'm not in any real hurry to get that done. So I'm probably going to go ahead and turn on the time lapse and let you guys watch me connecting these things together. What I plan to do is twist all the wires together with a little piece of lead wire, solder it together, put a piece of shrink tubing over it, and then I'm going to take that into the connector that I'm going to make. So let me get the camera set up, and I'll be back with you shortly. Okay, it has taken a little bit of time, but we have found our 4 bundles of wires, and we pulled them into the bundles, and then we re-ohmed them. I don't think we caught that in the time lapse, but I've dressed all the wires as neatly as I can. We still have a lot of wires to connect, but basically those bundles all come up to here. And I'm going to cut these wires, strip them back, and then attach a single wire to it and pull the shrink tubing over and shrink it, and then it's going to be connected into the female or the male end of the connector that mates with this connector. And the black wires will be brought up here and connected in also. And then eventually the wires from the credit wheel will also be brought up to this connector, but like I said, we're not doing that today. So that's one connector or one pair of 4 wires connected up, and I'll crimp a pin on there in a little bit. So I'm going to go do the other 3 off camera, and then I'll crimp the connectors on, and I'll bring you back when I'm done. Okay, I've got those 4 done, so I'm going to strip them, put connectors on them, buzz them out one more time so I'm sure which ones go where, and then I'll put them in this connector, which will mate up to that connector. Okay, the connector has been made and connected. I did make a mistake when connecting up the black wires, and I got player 1 and 2 swapped around, and I don't have a Molex pin extractor here, so it's going to stay like that for tonight. But tomorrow or next week, hopefully we'll be able to swap those pins around. All I need to do before we can test is put these wires into the power strip, and Mike, I need a screwdriver either. Power this up, I believe. Okay.
Check for smoke. Ready?
Yep.
Green light on.
Blue light on back here. You know, I just realized something. This is going to be kind of hard to test. because I have to be able to pulse 2 relays at once in order to get this to work. Let me see how I can do that. Well, first, let me hook onto ground, which is right there. And so I think I can pull this off. First we need to find out where player. Interesting.
What was that?
I don't know.
Was that on the plate?
It was on the play field. Must be here. Okay, so that energizes player 1. And then if I can take
Do you want to look at the schematic?
No, it won't help. I mean, it would help, but it would require reading. I didn't think this through real well.
That's the 10,000. Alright, we got 2 wheels turning at once.
Yeah, and that shouldn't be. I wonder if I can go to the pulse ones, if that would make it better.
Definitely better.
Okay, that's weird that we get.
I can see player 1 moving, but it's not turning.
Right, well, player. So, in order to energize any one relay, you have to go through, say, or to energize any one solenoid, you have to go through 2 relays. One relay is turning on the ground, and one relay is turning on the power. Now, I call it power and ground, but it's AC, so one's turning on the line, and one's turning on the neutral, or and that basically causes current to flow only through that solenoid. So when this bank of solenoids is activated, only this wire should have AC on it. However, these relays may have some circuitry in them to allow it to bypass current spikes and stuff like that. So when I pulse this and the current flows through here, there may be a little bit of coupling through that's allowing a relay on another bank to also energize. That's a guess, but it won't keep it up because the cap charges up or whatever's getting the pulse out, and then it stops. But this is AC, so it would have to be tiny little capacitors in the picofarad range, and they shouldn't hold a charge. Well, I'm back home, and on the drive back home, I realized what a stupid mistake I had made in the design of this this relay driver configuration thing. I mean, it was so obvious it was a novice first-year electronics student kind of mistake. Had these solenoids been DC solenoids, I could have rectified this mistake by adding some diodes to restrict back current flow, but I didn't do that. And since I couldn't do that since these are AC solenoids and current flows in both directions, you can't use a diode to block current flow in both directions. So I I'm actually lucking out by only having the relays chitter a little bit instead of actually activating. But I don't see any way of fixing this problem except for rewiring and adding more relays to individually drive each solenoid with its own independent relay instead of trying to work it as a matrix. Let me flip to the screen real quick and I'll show you why this matrix idea doesn't work, and then what we're probably going to have to do to fix it next week. So here you go. Okay, let's take a quick look at how I have these coils currently arranged. I have 4 rows, or in this case 4 columns, of select lines for selecting each player. So this would be player 1, this would be player 2, this would be player 3, and this would be player 4. And then I have 4 rows that select each of the scores: 10, 100, 1000, 10,000. So if I ground this point, then that selects the 4 coils that would be player 1. And then if I put power on the other leg of the coil, that should be the tens column, or tens row, then current will flow through here, through the coil, up, energizing this coil and making it run. The problem is so blatantly obvious that I'm not sure how I ever believed that this would work, but there are tons and tons of other circuit paths. So showing the original circuit path would be through here and down like that and out, but there's another circuit path down through here and through this coil and back up through this coil and through this coil and out. And there's also another circuit path down through this coil and through this coil and through this coil and out. And there's another circuit path down through this coil and through this coil and back up through this coil and out. So even though there's 3 coils and the current, the resistance of those 3 coils will add up, the fact that there's multiple coils in parallel will again increase that current until there's almost as much current going through this coil as there was going through that coil. And that isn't the end of it. There's another path down through this coil and through this coil and through this coil and up through this coil and out. And also from here down through here and through there and up through there and through there and out. And from here down, and you're getting the picture. There's lots of places for current to flow. Then there's also ones from here down through here and up through here and down to there and out. And there, through here, up through there and out. And then finally here, through there and out. So there's 3 current flows through each of these. There's 3 current flows through each of these. Yeah, and there's still more. I don't completely know all the math. I remember studying it in school 100 years ago about this, but obviously this is a crappy design and it will not work. So we're going to have to add another relay board. So just to show you what the plans are. So if you look at the board here, this is the relay board that we are currently driving this matrix with. I'm going to have to convert this to just drive 2 sets of players, and I'm going to need to add another relay board like this to drive the other 2 players. So if you look at this board right in this area right here, that's not showing up very well. Can I make it bigger? Right in this area right here is a spare port that I haven't used before. So what I'm going to do is mount a second board on standoffs right up above this board. I'm going to make a connector that plugs into this slot right here and then screws into the terminal lugs on the next board, on the board above this, and then I'm going to wire out the other two players there. So that's the solution. When we designed this board, we left plenty of extra ports available for expansion if we needed it, so we're just going to have to use it. If I had more space in the back box, I might put the board in this area or something like that, but this is right up against the wall and all of our cabling is coming in right here, so I don't think that's a good place to put it. So I think that stacking these two up will put all of the player relays all in one concise area, and I don't have to move any of the other relays on the board, so I don't have to redo any of the other programming except for my scorekeeping programming. So that's it, and you'll probably by next week see this new configuration installed, and we'll be rewiring those wires into the new configuration. So that's it for now. Thanks a lot for watching, and I still can't believe I made such a stupid mistake.